Let's talk about structures. The purpose of the structure is to collect related information. Generally, why I want it, I will tell you. Example, I have a student and I want to store some information about student. Okay. Example, some properties like student has ID, let's say name and marks. These three things I want to store. Then I have two ways. One is a basic way. So create one integer SID and create one character pointer P to hold string S name. Okay. So character pointer suitable name is S name. Okay, you can initialize it with like Raju if you want. Okay, so that you can understand it easily that what's the purpose of this character pointer to hold the string. Third one, marks, right? So let's say int marks. This you can do. But if you do that, there is no relation between student name, this student name Raju and this SID and this marks, right? But I want to have some close connection between them. I want to say that these are all related information and I want to make them as a bundle. Yes, in C programming you can do it. To do that, you have to write a syntax called struct like this, struct followed by opening brace and closed brace. In between them we can write all these things. Okay, when you do that, then your compiler understands that you need a new data type. So your compiler treats this entire thing as a new data type. That's why structure is also known as derived data type. Okay, so whereas integer is a primitive data type, character is a primitive data type, but now this entire thing, if you treat it as a data type, so I can say that this is derived data type. So this derived data type is derived from primitive data values, isn't it? Now this is about structure and we have understood the purpose of structure. What is that? To collect similar information or related information. Okay. Now here either you can write struct followed by directly left parenthesis or right parenthesis. Second one, we can write a tag here. Generally, most of the times I prefer writing the tag. Example, what is this information we are storing? Student information, right? Let's say info, student info. Then you write like this, struct student info followed by left parenthesis, right parenthesis. In that you write int SID, okay, and followed by every remaining thing. This is the declaration of structure. Okay, so why I am saying this is declaration, I will tell you. Whenever you write this kind of thing, then memory will not be allocated. That's why it is declaration. Okay, so we'll see one more example rather than this one. Let's say I want to have a point, like in geometry we use point, right? Like point to represent two integers, like example point 2 comma 3, right? So in geometry we use it. So to represent this point 2 comma 3 in programming, we can use struct. Okay, so here this is integer, this is integer. I want to hold two integers finally. Then I can do like this, struct point. Okay, then open the brace, close the brace, write int x, int y. When you do this one, then we are creating a structure. So new data type. Now how compiler understands this one is, compiler simply reads it whenever you write it and it says that, my dear user, I understand your syntax and I understand that what is point. Point is a structure which contains two integers. Okay, but memory will not be allocated. Whereas when you write a primitive data type like int x, then this is a declaration followed by definition. That means memory is also allocated. We know the difference between definition and declaration. Declaration just mentions the type of the data, whereas definition mentions the type of the data followed by it gives some memory, correct? So that's why when you write int x, are we getting memory? Yes. So are we understanding, are we telling the type of the variable? Yes. That's why this is declaration at the same time definition. But this one is only declaration. But how to have memory like this kind of thing? Example, I want to have a point kind of memory where that contains two integers, right? X and Y. For that there are two things. One is immediately after the declaration, write one variable name. Now I am writing the whatever you write now, that will become variable name. Example, if I say P, then what happens? P will become a variable of data type struct point. Example, when you write int x will become what? Integer. In the same way, when I write this entire thing followed by P, then it is like struct point P. That means P is a struct point kind of data type. Then now compiler gives you one memory box whenever this kind of instructions are executed. Okay. So finally, so when you write this entire thing, one box will be created for you, and that is P. On that there are two memory locations. Okay, this is just logical imagination. Okay, this is bundle now. What is that bundle name? P. And it contains two variables, one is x, one is y. Both are integers, right? They contain garbage values. Now, how to refer these two? To refer this entire bundle, we have to use the name P. So using that, but if you want to refer this particular memory location, the syntax is now p.x from now onwards, because it's a new thing for us. That's why we are learning the syntax for it. To access this one, we should write p.y. Example, I want to make this value 1, this value 2, because I want to create a point 1 comma 2. Then simply write p.x equal to 1, p.y equal to 2. Second thing, this is not compulsory to write p immediately after the declaration. What you do is first declare the data type. Yes, close it. Now when you do this one, your compiler understands that point is a this kind of data type. Point contains two fields x comma y. From now onwards, if you want any object of type struct point, you write like this: struct point followed by variable name. In the next line also we can write struct point p1, okay, struct point p2. So this is one more thing we should understand, because we don't know when we require this kind of data types, right? So whenever you want this kind of object, then simply say struct point p1 wherever you want, right, followed by struct point p2. If you do, then you get two boxes, right? But some students have this confusion: sir, x and y are the variables inside the point, right? Struct point. P1 is a struct point kind of object. P2 is also struct point kind of object. Then P1 contains two memory locations. One is x, y. P2 also contains two memory locations x comma y. Then is there any naming conflict? No, there is no name conflict, because this x and y are only visible under this box. That means only we can refer them through this variable, right? What is that variable? P1. So that's why when I refer p1.x, unambiguously this will be referred. Whenever I say p2.x, this will be referred. That's why there will not be any conflict. Understand? Now one more thing I want to clear here, that we can initialize structures also, like how we initialize arrays. If you want to initialize this, let's say p1, what you do is you write struct point p1 equal to, open the brace, close the brace, like an array. Right, how many objects we have inside? 1, 2, right? Then you write it 1 comma 2. Then order is important. So 1 will be given to x, 2 will be given to y. Similarly, you can say here p2 equal to 3 comma 4. If you do that, then this is the way they will be initialized. This is the initialization of structure. Okay. So far we have learned what is structure and how to represent it, otherwise how to declare it, and how to take the variables of struct kind of data type. Correct? Now we'll see how to create pointers to the structures. Okay. Question number 1, why do we need it? Then my question to you is, what is the purpose of having integer pointer? In the same way we need structure pointer. Okay. Example, you have integer x. What is this declaration to create, what is the definition to create integer pointer? Integer pointer y, isn't it? Now in the same way, try to understand. Simple, write the data type what you want and write the pointer symbol, then pointer variable name. Correct? In the same way, I want pointer to data type dash struct point. That's why you write struct point. This is the data type. For that I want pointer, that's why star. And what is the pointer name I want to use? P. So if I do that, then pointer will be created. And what I want to tell you is, whatever the pointer you take, the purpose of pointer is to just hold the address of the memory location. Now since All these memory locations are main memory locations of a computer, whether it is integer pointer or character pointer or floating pointer. For everything, pointer holds an address, and especially that addresses are memory addresses. I assume that, let's say, your memory addresses are 32-bit addresses. Then though whatever the pointer we have, like integer pointer, character pointer, everything will have same 32 bits. That's why, so struct point star p can be imagined as a single box. It's a single box. Okay, though your structure is a multi-box kind of thing, correct? So this is your structure point. On that there are two memory locations, correct? One is for x, one is for y. And what is this entire group name? Point, correct? Of course, struct point. Okay. Now what I want to say is, even for this big box, pointer is only single box. Okay, that also contains 32 bits, like integer pointer, character pointer. You should remember that. Now here, now we are going to have one address. I am going to keep an address. For that we need a structure first of all, correct? To have a structure pointer, first of all we need a valid structure. What I do is, how to create a structure? This is just declaration, already I told you. Let me have one structure, struct point, let's say a. Okay, let's say a is a struct point. Now already I have a box, this kind of box. Now what is this one? A, right? Now how to access this values? A dot x, a dot y. That's of course obvious. Now I want to have a pointer to this box. Then further syntax is, do we have a pointer? Yes, p. Then link it to this box. How to link this struct pointer to this box is simple. P equal to address of, what is the box name? A. This is the syntax to link a struct pointer to structure. Understand? So A is a real box, okay, and its address. What is this data type of A? See, A is a struct point kind of data type. And what is the address of that one? It's a pointer to, otherwise address of struct point is nothing but it's a pointer to struct point. And who is capable of holding it? Struct point pointers. That's why this is very well, legal statement. So P equal to address of A. Understand? This is, of course, is the best way of linking a struct node pointer to, or struct pointer to real struct. Okay. Now be careful. The compatibility is very important here. P is a struct point pointer and A is a struct point. That's why you can do it and it is legal. Okay. Now second thing, let's say you have a pointer P, then how to access this box? Let's say we'll try to fill values here. Then how to do that? I will show that one. Now we'll see how to access this box, okay, through struct pointer. First of all, let me link it again. P equal to address of A, isn't it? Now what I do is, I want to access this one. Then first of all, we know how to access this box with A, that is a dot x and a dot y. But how to go to A now? See the relation between P comma address of A. A is nothing but star P, correct? Whenever we pass address of A to P, then star P equal to A. Always you remember this point. Whenever you have a pointer to some variable, example here, P is a pointer to variable A. When you have this kind of relation, always I can replace A with star P. Okay. Now how to fill these values with A? First of all, write it a dot x equal to, let's say, 5, a dot y equal to 7. This was the usual syntax with using variable name directly. Now I want to use pointer P. Okay. Now P is a pointer to A, then simply we can replace A with star P. That is what I want to say. Now syntax for using pointers and to refer this variables x comma y is star p dot x equal to 5. Same thing. Star p dot y equal to 7. If you do that, same thing will happen. So these two can work as an alternative to a dot x and a dot y. Okay. Now there is one more syntax for this one. To access this memory using pointer p, we have another syntax, that one. So either write like this, otherwise you write like this. Star p dot x is nothing but p cap x. There is one more symbol is introduced, that is cap. Up to now we have not seen it. From now onwards we use cap to access members of a structure through a pointer. Okay, this cap we can use only with pointers. Okay, so whenever you write star p dot x, replace it, write p cap x. Now star p dot y is nothing but p cap y. It is like accessing a group or structure using a pointer. For that we use cap. It symbolically says that p is a pointer. Okay, so p cap x equal to 5, p cap y equal to 7. Okay, now this is about some of the details about structures, right? Now some more things I want to tell you. We can create a structure, otherwise we can allocate memory for structure using malloc also. How, we'll see. Example, I want to create this kind of box. What is that? A box with two variables x comma y. How to do that? Using dynamic allocation. Simple. So we have malloc, right? Use malloc. Okay, then write size of what? Size of dash you want. What is the data type you want? Struct point. So I want size of struct point only 1. That's why don't mention the star. Into either you write star 1, otherwise don't mention anything. So simply malloc size of struct point equal to left side. We have to, since malloc returns the address, someone should be there who should catch, or who can catch the address which is returned by malloc. What malloc returns? Already I told you, malloc returns the starting address of this struct pointer. That's why the suitable person who can hold it is struct node pointer. So what is that node? Point, right? That means struct point. So what is the data type? Struct point. I want struct point pointer. Struct point, let's say pointer. What is the name we give for that pointer? Let's say p. If you do that, what happens? I will tell you this one. Since struct point star p creates a variable p which is a struct node pointer. Okay. Now what malloc gives? Malloc gives you exactly a box which is nothing but struct point. So malloc is giving you one struct point box. That means a box with two sub boxes like this. One is x, one is y. Because you asked it, right? So this much memory will be given for you. Okay. Now how to access these two? That's why this return address, example, this entire box return address is 100. That 100 will be given to p. When you do that, so p will become a pointer to this box. Okay. Now I want to tell you one thing. What is the difference between this way and this way? What are the differences you are seeing? One difference is, in this model, A is a owner, I can say, which is referring this box. Otherwise this box has a name, correct? When you allocate some memory through dynamic otherwise malloc, such memory will not have any name. There is no binding with the name, correct? That's why such boxes, definitely their addresses should be remembered. If you don't remember, example, if you forget this address, that's it, gone. You can't access this memory. That's why always malloc goes with left hand side a pointer, where that pointer can hold the address of this box which is allocated by malloc, correct? The major difference is, here we have a variable name, but this box doesn't have variable name. Okay. Now for here also we created a pointer to that box using p equal to address of a. Here also we are creating a pointer to that box which is p. Okay. Now that's why syntax for accessing these two boxes again will be same. Since we have a pointer now, whenever you have a pointer, how to access any memory box which is structured, whether it is anonymous or known, doesn't matter. This box has a variable name, this box doesn't have variable name, but it doesn't matter. We have a box. Whenever you have a struct box, okay, then we can access that structure using indirect pointer p. So how to do that? Simply p cap x equal to something, p cap y equal to something. Example, let me write 5 and 7. If you do that, what happens? So this will be accessed and you get 5 here, you get 7 here. Understand? So now we have seen so many ways of creating the structure. One is like this, where we are creating a variable name like struct point a. Second model is dynamic allocation, where we are not creating the variable, but we are getting the memory which is required to hold two integers x comma y and along with one pointer. Why this is very important. If you don't have this pointer, still it won't give any error. There is no problem. It's not compile time error, otherwise there is no runtime error. But what happens if you simply do malloc of this one box will be created by your compiler with two variables x comma y, but there is no owner for it. Then suddenly you want to access it. How you access? In this model we have a variable name, but here malloc only gives you memory, and malloc returns something you did not catch it because you did not give it to the function. Malloc function you did not give to assignment. Then what happens? Then malloc simply returns something you did not take it. Then that is your problem. Then you can't access this one. Is it not like a memory leakage? There is a memory leakage here if you don't take the address of the box which is allocated by malloc. So there is a memory leakage. Be careful. Okay. And obviously whenever you want to deallocate it, we can do it. For that, just give the starting address of that box. That's why already malloc gave us starting address, right? Assume that let's say we have stored it in p. Then simply write free of dash p. Then again we can deallocate it. Old story, right? So that story which is related to malloc is not new to, or is not different for structures. For structures also it is same. Understand? So far we have seen structures with integers as members, right? Similarly you can have characters as members and also structures as members, which is interesting. Okay. Now example, I have a line with 2 points. Okay, point 1 p1, point 2 p2. Okay. Now p1 is, we know what is p1. It is a struct point, like struct point. Okay. So data type of p1 is struct point. Similarly p2's data type also struct point. Let me do like this: struct point p1 comma p2. Okay. Now I want to have a line now. How to declare line? For that, syntax is struct line. Try to understand the pictorial representation of that line. So line will have 2 points, correct? That's why. So struct line will have two members. One is point 1, point 2. What is that p1 type? Which is nothing but struct point p1. Okay. Now struct point p2. Let me erase these two to avoid the confusion. Okay. Just I was giving p1 and p2 here to illustrate what are the data types of p1 comma p2. Now see this entire thing now. So line is a struct. Okay. It contains struct point p1, struct point p2. You can now try to imagine what is struct point p1, how it looks like. If you have a line on that, struct point p1 is nothing but one point, like with two coordinates. We know that p1 will have two coordinates which are integers, right? So x comma y. Now similarly p2 also will have two coordinates, x comma y. Okay, so that's why it is line. Now how to create this kind of box, we'll see. Okay, for that simply write after this line, I am writing struct line, okay, L. If I do that, then so one structure will be created as you said, that is L. How to imagine that L, I will tell you. So L is nothing but contains one variable called struct point p1. Try to imagine how p1 looks like. p1 is a bundle again, right? This is p1. p2 is one bundle because it's struct. Okay, that bundle, if you reveal it, it contains two variables x comma y. p2 also contains two variables x comma y, right? Now how to access them? Example, I want to initialize p1, otherwise I want to use p1 and I want to fill these two values. What is the syntax? Simple. To go to this box, first refer L, right? Then to go to p1, p1 is a member of L, write dot L dot p1. But on that p1 you want to again refer this member x. So how to refer x? X is a member of p1. Then you write L dot p1 dot x and write whatever you want. Okay. Example 5. Similarly, example you want to refer this one. Then you write L dot p2 dot y equal to 7. In that way you can fill all that values. Understand? So this is about nested structure. Okay, so a structure in structure. Understand? One more important property of structures is, assignment. That means we can assign one structure to another structure. If you do that, what happens, we'll see. Example, you have a struct point P comma Q. Okay, then P dot X equal to, we know the already the structure point, right? It has two variables X comma Y which are integers. So P dot X equal to 1, P dot Y equal to 2. Then what happens is, if I write Q equal to P, then this entire structure will be copied to Q. Then so Q dot X also automatically will become 1, Q dot Y will become 2. The reason, this P dot X will be copied to Q dot X and P dot Y will be copied to Q dot Y. So that is what one important point you should observe. So second thing, while returning from function, that means, if a function returns a structure, and if I take that return value as an assignment, then still again same copying will be done. I will show with one example. Example, I have a struct point Q. Okay, then if I assign make point 3 comma 4 to this Q, what happens is, we'll see. Just execute and understand and you learn it. Okay, so let me blindly execute this make point. So make point is returning struct point. Okay, we'll see that later. So make point contains two variables X comma Y. Let me note down them. Then there is one struct point P. Okay, that means how to imagine P. P is a box, very big box. It contains two subfields. One is X comma Y. Don't get confused between this XY and this XY, right? They are different. Now P dot X, this one equal to X. So what is X and Y now? Whenever we call make point, then X gets 3, Y gets 4, isn't it? So 3, 4. Then when you do P dot X equal to X, this will become 3 and this will become 4, isn't it? Then we are returning P. So we are returning this entire P, right? So to Q. When you do that, what happens is, again this entire value, that means the structure will be copied to Q. So when you do this one, what happens is, Q dot X, Q also will have X and Y, right? Then Q dot X will get what? 3 and Q dot Y will get 4. That is what. In that way, we can, initialize Q using function call. That is what I want to teach. Okay. So that is one more property of structures. Okay. Now we have seen initialization of structures in a constant way. That means we have taken a structure and we initialized it. Second one, so using another structure by copying that value, we can initialize the structure. Third one, through the function call also we can initialize the structure. Further, this is the syntax. Okay, this is all about structures. Now we'll see how to pass structure as a parameter, and if we pass it, then what kind of things we can do, we'll see. Let me execute this program directly, and already I am assuming that we have a struct point, the data type int x int y. Now struct point A. So always, one good thing is, initially when you are learning programming, just represent every data as a box so that it will be easy for you to understand the flow. Okay, so we have struct point A, one memory box will be created, and we know that there are two variables inside it, one is X, one is Y. Okay, now let's say assume that this entire box address is 100. Okay, now maybe if this is integer, if this integer occupies 4 bytes, then this will be 100 to 103, 100, 101, 102, 103. Then this box occupies, let's say, 4 bytes. This will be 104 to 107, maybe. Okay, they may be contiguous but may not be. Okay, don't assume anything about these particular memory addresses. Okay, assume that, let's say, this entire box address 100, then we are calling mystery with address of A. That means we are simply passing 100 comma 3 comma 4. Since C programming is a call by value kind of thing, then what happens, 100 will be passed to struct node pointer P. Already I told you one thing, this is a struct node, and address if you pass, then the person who takes it should be pointed to that. That's why P is a struct node pointer. Perfectly right. Then P is a single box, right? So that box now going to take 100. Now X is going to take what? 3, and Y is going to take 4, right? Now, first step is p cap x. Question number 1. What is p? It's a struct node pointer. Whenever you have a struct node pointer, so accessing its members, like since p is pointing to this box, okay, then to access these members we can use cap. Already I told you. Then use it, p cap x equal to x. What is x? 3. Then indirectly we are again coming to this memory and it is alive. Since main is not completed, then it is legal to use it, and p dot x equal to 3 and p dot y refers this one and it gets 4. So finally this mystery is initializing this struct point a's values, okay, through a function called mystery, right? So this is all about passing the structure as parameter, okay.